Hey TechKnowStuds! Our CDs and DVDs are what we call optical media. The word optical just means relating to sight. And what sight is our eyes determining or interpreting light waves that are coming into them. Well, the same thing happens with these CDs and DVDs, this optical media, as we reflect light off of it and then determine what it's telling us, what is the data stored on it. And the type of light that we use are these lasers. So we shine lasers off of this in order to interpret the signals that are on this CD. One thing to understand is that we do use lasers for this, not just regular light. Laser is a very focused beam of light. So we see right here, it's a very focused beam rather than just a regular flashlight is all over the place. Another important concept to how optical media works is that we use reflective surfaces. So what we see right here is the lasers coming out and hitting this DVD, reflecting up, and then I have this mister going so we can actually see the reflection and what's happening over here. So what we have in this diagram is a reflective surface. We have a laser. We have that laser beam that's shooting off, reflecting off of that surface, and then we need some sort of sensor to be able to detect that light. So in this example right here, here's the laser, here's a reflective surface, and then this is going to represent our sensor that's sensing whether it's a 1 or 0 or not. To store data and read data off of CDs, somehow we need to disrupt that reflective surface. So I'm just going to use a note card here as an example with holes in it and then move it along, and as what you can see is sometimes it gets reflected and sometimes it doesn't, creating 1s and 0s. So what we have here is we have some sort of backing to all of this. Maybe it's some sort of plastic that holds this all together. The next is we have a reflective surface, and then on top of that we've got a protective layer right here. And all we have to do now is if we want to have a signal on here, we can carve out certain areas that don't have reflective surfaces on it. So we can see that there are certain areas that are carved out. So now what that's going to happen is that laser is going to reflect and get a signal off of some of it, which would be maybe a 1 here, and then it's not going to reflect off of other parts. What's going to happen is it's not going to reflect here. The sensor is not going to receive anything, and so we categorize that as a 0. So let's see what happens when this laser goes across this disk reading the data. Now there's really two methods that we could read from this disk. One of the methods is that we could have an absence of a reflective surface. So that's what we've been covering, is we have a reflective surface that doesn't exist in these spots right here, and so therefore those are 0s. But the other way that we could do this is we could actually block light on this other surface here. We could block light from hitting that reflective surface. I'm just going to call one of these methods the subtractive method, which is we're eliminating some of the reflective surfaces to create that signal of 0s. I'm going to call this other method additive, that we're adding something that's going to block the reflective surface, so that way it's going to represent 0s. And here's an example of where that laser now is hitting a blocked content there, so that way it's not getting to the reflective surface, so then the signal is not getting to the sensor. So therefore that would be a 0. There are CD drives that we can write data to CDs. What we have is we have some sort of laser that superheats the chemical here, making it opaque. That is, making it so that way the laser can't shine through it. And so that's how we write data to some of these CDs. Now there are different technologies and they work a little differently, but essentially that's one of the ways that we write to these CDs.